I'm happy to see you once again in class. Yeah, and I can see that you've already understood some introduction of indices, what all that is all about, and also how to relate the base with the exponent with the power, and also you've already mastered some basic terms and terminologies that we'll be using in this topic. Now that you've understood that, I want us actually to take it to a step further. In this session, we get now to cover the laws that we'll be using to tackle indices questions. And it's important to note that all the questions that you'll ever do concerning indices, you'll be tested from the formulas and from the laws that you'll get to tackle in this session. However, I'm going to make it even much simpler for you. So what you're going to do is that we are going to divide the laws into two. In this session, we are going to cover the first part, which will get to cover 3 laws. And then after that, I'm going to give you some simple quizzes, and then you'll get to test yourself. Then if you will have mastered the first 3 laws, then we can move on to the next 3 laws. So let's get into it together. So the first law that is commonly used in indices and logarithm, it is the multiplication law. And actually, before I give you this law, let me just refresh your mind a little bit on what we've already covered. You remember the moment that we had 2 to power 3, and assume also we've got another term like 2 to power 2, and we want to multiply these terms. Remember what we said in the previous session, that when you've got a case like this one, that is 2 to power 3, what we usually do is that we usually take 2 and we multiply by itself 3 times, such that we have 2 multiplied by 2 multiplied by 2. And now here we've got a multiplication sign, so we are going to keep it on hold, and then we go to the second term where we have 2 to power 2, which is equivalent to 2 multiplied by 2, just 2 times like that. And then if we can try to simplify this using the knowledge that we have acquired so far, then this would imply that the whole of this multiplication would be equivalent to 2 to power something. But how do we get that power? We get that power by counting the number of times this number that we have, which is 2, has been multiplied by itself. Let's go ahead and do that. So we'll have 2 to power. We have the first multiplication happening here. We've got the second, the third time, the fourth time, and the fifth time. So this would all converge to 2 to power 5. But then again, when we look at these terms very closely, there's something that you are going to realize and notice, and actually that's what I want us to check. We have a 3 here and we've got a 2 here. Therefore, what is actually happening is that we are having these terms here, that is 3 and 2, being added together so that we have a 5. And now we have this 5 appearing here at this power. I believe that this was a good moment for you getting to see how all this is getting to connect together. Therefore, that implies for a general term, suppose you have been given a term like a, and that number, it is raised to a certain number that you don't know, power m, and then that is multiplied by the same number, which is the base a, and then it is raised to another number, which let's say we don't know, it's n. Then this one should be equivalent to a multiplied by now these powers being added together, that is m plus n. So this is the general formula for the multiplication law. This is very important, and actually you realize that in most of the questions that we'll be doing in some of the upcoming sessions, we'll be using this law a lot. Therefore, it's very important that you ensure that you master it very well. Just to ensure that you've really understood how it works, let me give you another final example before we move on to the next law. Suppose that you've got something like x to power 2, and then this one is multiplied by x to power 5. What do you think could be the value of this one? Well, what we should do is that we should take the number that we have for this case. It is the unknown value, which is x, and then we write it there, and then we pick the powers that we have, that is power 2 and power 5, and then we add them together. That is 2 plus 5, we write it there to have x to power 2 plus 5, that is 7, and that would be the answer for that. So that is how we apply the multiplication law of indices. With that, let's move on to the second law of indices, and we have it right here, that is the division law. Just to test ourselves a little bit before we get into that law, suppose that we have something like x, or even 3 to power 5, or let's say 3 to power 7, and then it is divided by 3 to power 2. You see this one, it would be equivalent to 3, and then we have this 3 being multiplied by itself 7 times. Let's go ahead and do that. Therefore we would have something like 3 multiplied by 3 by 3 by 3 by 3 by 3, and finally another 3. Are these 7 of them? 1, 2, 3, 4, 5, 6, 7. Yes, that's quite perfect. And then we have at the denominator part, what we have is 3 to power 2. Therefore that is 3 multiplied by 3. Therefore, to simplify this, what you would do is that you would take this 3, we divide by 1 3 that is there, and then we take this 3 from this. You see, initially these 3's were 7 of them, and the 3's that are here were 2 of them. Therefore what has happened is that we have taken this 7 and we have taken these 2. Let's put them here. We've taken these 7 and then we have minused these 2 over here to remain with 5. And how many 3's are here? There are 1, 2, 3, 4, 5. So what is happening here is that these powers are being minused or are being subtracted. So, and what law do we get out of this? We get a law that if we have got something like 3 to power 7 and this one we are dividing it by 3 to power 2, what is happening here is that we are retaining our 3, which is right here, and then what we are doing to the powers is that we do 7 minus 2, and this is giving us a 3 to power 5. Therefore what we are doing is that we are subtracting the powers, and actually we can be able to get a law out of that, and that is when you've got a number like a to power m and that one is divided by a to power n, the result that we get is a to power, we take now what was there in the first term power, which is m, and then we minus by what is there in the second term power, which is n, and this is actually the formula that we get for the division law of indices. Very important. Ensure that you also do get to master it. Let's get into another law, and then from there we can do a few quizzes and we can do some exercises together to see whether we really understood that. For this one, you may not have full concept for it. That's why I would really want us to do it together right here. So when you have got something like, take an example of 2, and this one is raised to power 3, and then again this one is raised to another power like 2, then what this would imply, it is like we have 2 to power 3 and then that one is multiplied by itself again, that is to 2 to power 3. But then how would we be able to deal with that? What we should do about that is, like we have 2 and then this is 2 to power 3, it is multiplied with 2 by 2 again, so that is the terms that are there in the brackets, but then we have this power that is here too. So to open up this, then that would imply that we have 2 multiplied by 2 multiplied by 2, and then we multiply everything that is inside by itself again, and that would give us 2 to power 2 multiplied by 2 again, and this would give us 2 to power. We now find the value of this power. The value of this power would be 1, 2, 3, 4, 5, 6. But what has happened here? What has happened here is that when we had 2 to power 3, and then this one is to power 2 again, what has happened is that we've taken this inner power, which is 3, and we multiplied it by the power that is outside, which is 2, to get 2 to power 3 times 2, which is 6. And that is the point that we get to have a formula for this. And the formula for this, the one that we've used, it is now what is called the exponential law. But how we are able to represent that law in terms of something that we can be able to read is that when you've got a case like a to power m, and then that is raised to another power n, then that is equivalent to a to power m multiplied by n, and that is equivalent to a to power m n. And this is the third law that is commonly used as we do this topic, that is called indices and logarithms. So ensure that you do really master these 3 laws. We have the first one there, that is the multiplication law. We have the second one there, the division law, and we have the third one, which is the exponential law. So what I've done is that in here below I've set some questions that you can be able to do, and immediately after you submit, you'll be able to see if you got wrong, if you got it right. If you get it wrong, don't worry, we are here to learn. You'll be able to see how you should really tackle them. But when you at least get 70%, you'll now be able to move on to the other topics, or rather to the other 3 laws that we should cover. For now, just have some fun, enjoy yourself as you do tackle those questions. I'll see you in the next session.